And I am live. And my screen is not stuck, and my camera is bad as always. Now, shit, I got logged out. Shit, yep, now it's okay, I guess. Yep, my progress is back, and today we will complete this Python course, which has, I guess, 5 chapters remaining. And this is very redundant. Yep, we have to start with dictionary, then we have sets, errors, challenges, and a quiz at the end. And we cannot do any of the exercises because I do not have the premium subscription, which is fine, And this is also redundant. So, very basics about Python, which I already kind of know. Yep, dictionaries. Dictionary in Python are used to store data. I should not look down. Yep, just do it like that. Dictionaries in Python are used to store data values in key value pairs. Dictionaries are a great way to store groups of information. Use curly braces. Yep, that is how we define a dictionary. Here, the car variable is assigned to a dictionary containing the key. These are the keys, brand, model, years. The keys corresponding the values are these. Assignment complete. The getChar record function, it takes characters these and as individual inputs and returns a dictionary. So make a dictionary like this and then just return it. That is it in the assignment. Duplicate keys. Because dictionaries rely on unique keys, you can't have two of the same keys in the same dictionary. If you try to use the same key twice, the first value will simply be overwritten. Okay, and the assignment would be easy. And this is redundant, so I am just skimming through it. Right, this is very redundant and basic, and when I am actually doing some coding, I will go into it. uh, I will, I can just research when I am actually coding, so and not waste a lot of time in here solving these simple problems. Dictionary elements must be accessible somehow in code, otherwise they won't be very useful. Yep. A value is retrieved from a dictionary by specifying its corresponding key in square brackets. The brackets look similar to indexing in a list, like that. Which kind of brackets are used? Square. See, that's just easy because this is for people who are new to development. Setting dictionary values. You don't need to create a dictionary with the values already inside. You don't need to create a dictionary with values already inside. It is common to create a blank dictionary, then populate it later using dynamic values. The syntax is the same as getting data out of a key. Just use the assignment operator to give that key a value like that. Pluto. And which is the correct syntax? This one, first one. Yep, first one is the correct syntax. Updating dictionary values. Just use the assignment operator like that. If you set the value of a key that already exists, you will end up just updating the value of that key. Yep, it's common. What happens if you assign a new value to an existing key? The value updates. Yep. What are the other options? A collision error occurs. The key and values are deleted, which is horrible. Deleting dictionary values. Del. Yep, del and this, which is similar to they used, which is similar to shit. What the fuck did they used earlier to delete something? I guess it was to delete some element in a list, right? To just delete some element in a list. In that case, also we use the del keyword. You can delete existing keys using the del keyword, like this and dictionary, and then the thing that you wanted to delete, right? Deleting keys that don't exist. Notice that if you delete a key that doesn't exist, you will get an error. Error here. Key doesn't exist. What happens if you delete a key that doesn't exist? Error. The existing value is returned, but it does not exist. Counting practice, checking for existence. If you are unsure whether or not a key exists in a dictionary, you can use the in word. Ford in cars, GMC General Motor Company in cars. iterating over a dictionary in Python. Yes, for names in the dictionary, this equals this, and I can print it. That is cool. Yep. This when using the n keyword, n name gets the value of the key, and then indexing into the dictionary using that key, I get the value. That is how it works. We can iterate over a dictionary's keys using the same no index syntax we used to iterate over the values in a list. With accessing to the dictionary's keys, we also have access to their corresponding values. Yes, and this is so much abstraction above the low-level language that it feels like Python interpreter would be one of the most complex interpreters out there. Is Python interpreter complex? Well, of course it is complex. No, the Python interpreter is not considered complex. In fact, it is known for its simplicity and user-friendly design, making it one of the easiest programming languages to interpret. I'm not talking about the language, I'm talking about the interpreter. What exactly is okay? Okay. I will make my own interpreter. I have a book in mind. Creating interpreters, I guess it is called. As of Python version 3.7, dictionaries are ordered. They have a hierarchy, they are ordered. In Python 3.6, or earlier dictionaries were unordered. Because dictionaries are ordered, the items have a defined order, and that order will not change. Unordered means that items do not have a defined order. So you couldn't refer to an item by using an index. The takeaway is that if you are using Python 3.7 or later, you will be able to iterate over dictionaries in the same order. You'll okay when iterating over dictionaries using the in keyword. Dictionaries before 3.7 were unordered. This is optional, and quest status, this is assignment. Fantasy quest needs a way to check the status of an individual character, and a key which has some value, a key which has some value inside it, and stuff. Now, moving on to the next chapter, sets. Sets are like lists. Sets are like, okay, let me describe what are sets. Sets are like lists, they just contain values, but those values are not ordered, and no two values repeat. And if you want to add some value or remove some value or check whether a value exists in the set or not, you have the interface for set. Unordered, and they guarantee uniqueness. Yep, no two values are same. Only one of each value can be in a set. Only one of each value can be in set. Fruits equals to this. Yep, and add values. To add value, I can just do the set, add, and then value. Okay, set uh, lists, tuples, dictionaries, and now sets. Nope, no error will raise if you add an item already in the set. It will just do nothing from the perspective of the programmer. Empty set, because the empty brackets syntax can create an empty dictionary. To create an empty set, you will need to use the set function. To create an empty set, you will need to use the set function, because if I were sets are represented using this these curly brackets, and yeah, if I want to assign and initialize, declare and initialize a set, I can use the square curly brackets. But if I want to create an empty set, then I will have to use this class, which function, which returns as empty set. Iterate over values in a set. Order is not guaranteed for something in something. And then the assignment. Moving on, and that is the same theory. And how do I remove an element? Dot remove. I suppose this should be it. Dot remove. They did not say about remove, but I suppose it would be dot remove. What is the type of my value in the type statement equals my value? It is a dictionary. And then which would be a good use of a set? To store IDs, user pairs, user pairs, to store IDs, user pair, to store all possible spells in a game, to store all enemies in a game by difficulty. Well, uh, to store all enemies in a game by difficulty, I would need order, which is not guaranteed by set. So last one goes out. To store all possible spells in a game. Well, a spell would not do two different things. Uh, yeah, a spell only does one thing. Therefore, I cannot be adding the same spell which corresponds to other things at the same time. So that is a reasonable guess. To store ID, user pairs. What is user pairs? And if we are storing ID, then I would like to randomly access any ID in not randomly access, but orderly access the specific ID that I want using an index. So this also requires an order, which is not guaranteed by a set. So second option, to store all possible spells in a game, seems viable. Now duplicates, which is conditional, optional. Players are complaining that they aren't able to see their collections easily. Currently, collection item is displayed. Every collection item is displayed, even the duplicates. Players who want to see each artifact once artifacts are mm, fucking hell, artifacts are blurriness or mischromatization, colorization of pixels at edges when formatted in a JPEG format. Yep, players only want to see each artifact once, but this is not the same artifact, to be clear. Players only want to see each artifact once, even if they have collected more than one of them. So yeah, dictionary, store them in a set of vowels. You have been hired by a blogging company and they are asking you to analyze one of their recent posts to determine the number of vowels represented in their paragraphs. Huh? I can of course do that and also skip this. Errors. That is cool. Errors. Go up. Yep. Errors and expectations in Python. It's only been 30 minutes and I have completed 2 chapters, which is cool, which is fine. You have probably encountered some errors in your code from time to time if you have gotten this far in the course. In Python, there are two main kinds of distinguishable errors. Okay. Syntax errors, that is, I'm not writing the language properly, and exceptions, syntax errors. You probably know what these are by now. A syntax error is just the Python interpreter telling you that your code isn't adhering to proper Python syntax. This is not valid code, so it will error. Oh, this line itself is not valid code, so it will error. If I try to run that sentence as if it were valid code, I will get a syntax error. Syntax error. Now, exceptions are the second type of errors. Even if your code has the right syntax, however, it may still continue cause an error when an attempt is made to execute it. Errors, logical errors. Errors detected during execution are called exceptions. Detected during execution are called exceptions and can be handled gracefully by our code. Yeah, exception. Like, like exceptions. Yep, you can even raise your own exceptions when bad things happen. Syntax error, division by zero, something like that. Python use a try except pattern for handling errors. Try this division by zero, like I said, except except this exception. What is this exception? This exception accepts every exception. This exception represents every exception. So try this, and if there is any exception, then do this. The try block is executed until an exception is raised or it completes, whichever happens first. In this case, an exception is raised because division by zero is impossible. The except block is only executed if an exception is raised in the try block. Try, the fall of try. If an exception is raised in the try block, if except block is only executed then. If we want to access the data from the exception, we use the following syntax. Accept this as E, and then I print E. Wrapping potential errors in try except blocks allows the program to handle the exception gracefully without caching. Wrapping it in try except block. Yep. Try except review. Try this. The try block is executed until exception without caching. Yep, that is the same. If no exceptions are raised in the try block, if no exceptions are raised in the try block, the program just goes on. No exception, no. And the exception block executes, no. The exception block won't execute. Yep. If an exception is raised outside of the try block, it stops the program. The program crashes and prints exception. The exception is automatically caught. Nope, the first one. Now we got a video with 5-minute video which is cool. Raising your own exceptions. Errors are not bugs. Okay, that is okay. Errors are not something to be scared of. Every program that runs in production is expected to manage errors on a constant basis. Our job as developers is to handle the errors gracefully and in a way that aligns with our users' expectations. Let's see.
Let's talk about the difference between bugs and errors in code. And I think this is an important topic because a lot of newer developers don't think quite appreciate the difference between bugs and errors, because from the user's perspective, like in your pre-developer life, I think these two words sometimes get maybe conflated or used synonymously, but there's actually a really big difference. So let's give some examples. An example of a bug would be something like the program crashing. Let's say like your application crashes on maybe some specific user input. So say you have like an online game, if someone types the word crash into the chat, the game just crashes. It's all over, right? That would be a bug. It's basically unexpected. This is the important part. Unexpected.
Unaccounted for.
It's unexpected behavior is what a bug is. Okay, an error, on the other hand, isn't necessarily a bad thing. It's just something you plan for. So, for example, an error might be, again, using the example of an online game, it'd be like internet connection lost.
Oh,
Right? So you're writing your code. You have to
that is
plan
an
for the
error.
fact that it's possible that the person running your code, the person playing your game, essentially loses their internet connection. That's not a bug in your code. There's nothing you can really do about that as a software developer. But it's something you need to plan for, and it's something you need to handle. So errors are expected, and we handle them. Right? We handle errors.
Right.
Okay. So bugs and errors, the big difference is bugs are always bad. Like if you have bugs in your code, you need to fix your code, right? And what that means is, so say a user encounters a bug, they say, hey, my program's crashing, or hey, this sword is supposed to do 250 damage, but it's actually only doing 100 damage. Like the only solution to a bug is to go fix the code. So you go fix the code, right? When an error occurs, hopefully your code already is built in such a way that it handles it. Now, it's worth pointing out if errors are happening and they're not being handled properly, then that is a bug, right? But the bug isn't the fact that the error is happening. The bug is the fact that you're not handling the error properly, right? So,
Hmm.
what is an error? From a more literal perspective, what is an error in code? Well, if you're in Python, the way errors happen typically is that the developer actually raises them intentionally. So there's this kind of this keyword, right? Raise. So you can raise an exception. And in Python, an exception is an error. That's just the word used. In JavaScript, you would throw
True.
an error. And in Go, you would return an error value. Right. So these are things that we actually plan for in our code. Right? We're raising exceptions, we're throwing errors, we're returning errors, and then when those errors happen, we are actually writing code that does something. So, for example, say internet connection was lost. The way we would handle that is we might do some retries, right? So we're sending a network request, it fails because there's no internet connection. Maybe
Network
we wait 5 seconds and we
request.
try again, right? And then we wait 10 seconds and then we try again. That would be one way to handle an error. Another way we can handle an error, this is a pretty common way, is just to alert the user. So,
Hmm.
for example, maybe we require 8-character long passwords. The user enters 6 characters. We throw an error, and the way we handle the error is by telling the user, "Hey, you need to put in another 2 characters into your password." Um, so that's errors. And really, if you get nothing else from this video, I just want you to understand bugs are always bad. The definition of a bug is something unexpected happening in your code, and the only way to fix it is to go back and work on your code. Find where your code is doing something where you didn't expect it to be doing that thing, right? You expected a sword to be doing 200 damage. It's only doing 100 damage. You have to go find in your code why that's the case. Whereas with errors, if errors are happening, as long as you're handling them gracefully, that's all you need to do. So hope this helps.
Yeah. Thank. Uh, when something in our code happens that isn't the happy path, we should raise our own exceptions. For example, if someone passes some bad inputs to a function we should not be afraid to raise an error to let them know they did something wrong. An error or exception is raised when something bad happens. An error or exception is raised when something bad happens, but as long as our code handles it as users expect it to, it is not a bug. A bug is when code behaves in ways or users ways our users don't expect. For example, if a player tries to forge a sword out of a metal bar, we might raise an exception if the game doesn't support crafting a sword from that metal type. And if metal bar equals bronze, then return bronze sword. This is if it is steel, then return steel sword. Else raise an exception. Invalid metal bar. However, there is the expected behavior of the game, so it's not a bug. It's an expected behavior of the game, so it's not a bug. If a player can forge a sword out of gold, that may be considered a bug because that's against the rules of the games. Don't catch your own exceptions. As a rule of thumb, you do not want to catch exceptions you raise within the same function block. For example, if this, try this and accept it right here. Instead, the caller should handle any potential error by wrapping the function call within a try except block. Okay, the caller of the function should handle the error. Right. Move on. Not doing the assignment. Erasing exceptions overview. Something bad happened. Software applications aren't perfect, and user input and network connectivity are far from predictable. Despite intensive debugging and unit testing, applications will still have failure cases. Loss of network connectivity, missing database rows, out of memory issues, and unexpected user input can all prevent an application from performing normally. It is your job to catch and handle any and all exceptions gracefully so that your app keeps working. When you are able to detect that something is amiss, you should be raising the errors yourself in addition to the default exceptions that Python interpreter will raise. Yep, I can raise errors on my to keyword to raise an error is raise. That is it. like raise. Good code doesn't need to handle errors. It should be error free. No, false, false, false. And good code needs to handle error because errors will happen. Errors are not a bad thing. They are expected due to some certain customer behaviors. So you have to write code that handles an exception, an error. Different types of exceptions. Yep. We haven't covered classes or objects yet, which is what an exception really is at its core. An exception is an object that is returned. Okay, fucking hell. We will go more into that in the course on object-oriented programming, which will be later. Okay. For now, what is important to understand is that there are different types of exceptions and we can handle them differently depending on the situation. Some exceptions are more specific, like zero division error or index error, and some are more general, like the base exception. Zero division, okay. Some are more general, like the base exception error. Like try this, and if there is a division by zero error, then print zero division and except if there is some other error as e and print that e. This print nums2 which does not exist, and if there is an index error, then print index error. If there is an some different error, then just print that error, which will print division 0 and index error. Why specific exceptions come first? Because if there are general exceptions being accepted before, then they will be printed. Right, they will be handled first. Handled first. When handling exceptions, it's important to catch the most specific ones first, because Python stops checking once it finds a match exception handler. If you catch a more general exception first, any specific errors will never get handled individually. Any specific errors will never get handled individually. In this case, the general exception will catch the error before the index error can be reached, and the manager and the message index error will never be printed. Yep. Errors, as in the example, I can use as to take in errors as aliases. Right. The default behavior of print is that it will print the string representation of whatever object is passed to it. In this case, it will print the error message. The string representation of whatever object is passed to it. That is important. That is important. As you have noticed, there are many types of exceptions. Many specific exceptions are built into the language, like index 0 and zero division error. And almost all exceptions count as parent exception type. What differentiates exceptions are their types, not their string descriptions, their types. Okay, this is important to know when handling errors. If you are interested in the official documentation on all the built-in errors, I can CLSA refer to the following code for the question. Raise exception zero division. Except this, refer to the following code for the question. Oh, what will this do? Zero division. This will not handle and crash the program, I suppose. As you have noticed, there are many types of exceptions. Many specific exceptions are built into the language, like this and this, and like index error and zero division error, and almost all exceptions count as the parent exception type. What differentiates exceptions are their types, not their string descriptions. Their string descriptions do not differentiate them. Their type differentiates them. This is important to know to handle modular more errors. Let me see this. Good 9 minutes and cd python error.py print this python 3 error.py, and yes, like I said, error. And if I to zero division error. I guess this also will just erase an error. Yep, like I said. But if I do this or not this, but zero division error, I guess that should not erase it. That gets handled. That is cool. In the code sample, what will happen? The program will crash with an uncaught exception. Yep. In the program example, what will happen? Try raise zero division, except this other, it will print other. In the program, what will happen? I'm doing this, other will be printed. And to not mandatory challenges. Okay, we are on the second last thingy. Challenges. In this chapter, we are going to practice applying the skills and concepts we have learned while building fantasy quest. And I won't be able to do any of them. Write a function called, and after this, I guess I will do a couple of add-on of lead code problems in Python. That would be cool. I'll do some lead code problems. Write a function called num sum n that adds up the numbers from 1 to n. That yeah, I can do that. I can do that. That is, I guess, easy. Assignment minimum number in the Python. Okay, find minimum. Given a list, find the minimum number. The next, remove non-int ints. Okay, remove the numbers which are not int. I can use the type function, which will tell me the type. Factorial, find the factorial. That is, I have written it in assembly. Let me write it in assembly right now. Fact.s shit. Yes, how do I define the dot data section? Yep, right like that. And fmt dot as keys and factorial is percent d and the new line, right? And that is it. In the dot text section, I have dot align at 2 bytes and then dot global main and main. Inside main, I will should I take in the number that I want to print from the user? Well, first of all, I have to store pair the stack pointer x29 and x30 onto the stack, which that is the wrong format. X29 and x30 onto the stack with a pre-increment of 16 with this the pre-increment of 16, and after doing that I will get some space onto the stack by sub sp store into xp what 8, right? That should be enough, and yes, that is how I will give input to the printf function. Now let me write a fact function, a fact label, which is not if, compare x0 with xzr, and if it is whoop, if it is 0, yes, this will be called. Yep. If it branch if it is equal, not equal, how do I want to compare it? If it is less than 2, x2, can I compare with immediate value? If it is less than 2, then branch not branch, then return 1. Yep, if it is less than 0, if it is less than 0, then move into x0 1 and return that. Then branch to end fact, and these two will come in end fact, right? Move one and this. Otherwise, if it is not the case, then move into x1, whatever is the value in x0, then get the factorial of -1, then sub x0 0 by 1, and to get the factorial, I'll branch link to fact, and that should give me the factorial. And then I will multiply and store into x0, multiply x0 and x1, and then return. Yep, that is how this function would work. Now I will move into x0. Let's say 5. It should return 120, and after getting 5 into x0, I will branch link to fact. Oh shit! Yep. Store pair x29 and x30 onto the stack with a post 3 offset of 16, right? And before returning, I would like to get them back and then return end fact, right? Here I am ending fact, which is cool. After doing this, I will get back a store and ldp29 and x30 from sp with a post offset of 16, and do the same thing here, right? Which is the last thing that I do, and then it is the end. This fact, I will have the factorial in the 0th register. I will move it on to the stack by str store x0 and sp stack pointer, and now I will get the address for the format string, which is x atrp, get a page address for into x0 for fmt at the rate page, right? And add to x0 the fmt page offset, right? And now I have everything in place. I can just branch link and call printf like that, and then I can just return after getting the x29 and x30 registers back from the stack with a post offset of this clang fact to dot/out. Have I lost it? Right, there is a bus error. Get address, page address in there, and then get add page offset to x0, and right, that should work. And oh yes, I subtracted this, right? So before doing this, I will have to add to xp, add sp 8. Bus error again. And why the fuck am I even doing assembly? because I want to just see what the fuck is happening. Right, I do this and then branch link factorial with 0 in there, right, and I store whatever is in x0 onto the stack, right, and then in this I print this, right, printf, and then I add to the stack pointer 8, which is cool, and then I load where back. Okay, this function is cool. Now this, after calling the fact function, I do store the where, right, and then I compare x0 with 2, right, and branch. Yes, I'm branching, just branching with no particular reason. I'm just branching. Branch if less than, if x0 is less than 2, then branch, and come here, right, return 1, right, return 1, 16, 16. Yep, branch link. This should only cause a logical error, not a bus error. And here I'm doing branch less than and subtract, and yeah, branch link to fact with subtracting x1 from x. And I should go to the washroom for a minute or two, and I'll be right back. Shit, I just realized I am so goddamn stupid. This is not a factorial function. This is somehow trying to calculate Fibonacci with some stupid weird variation. This is not a factorial function. If x is equal to 0, right, b eq, if it is equal to 0, then just return. And I guess a loop would be much better here than this stupidity. Right, a loop would be much better. And first, yep, this, and yeah, let's see if I make this, and let's see if it is working, printing 5 at least. Yes, it is not printing 5, so error lies in the main function, in this main function. What is the stupid thing that I am trying to do? Right, plus minus 16 with then immediate offset, and then load with not immediate offset, subtracting from the stack pointer 8, right, 8 is, subtracting 8 is cool, right, it is very cool. Let me just in case, subtract 16 from the stack pointer, and branch link printf branch link print if store x onto the stack pointer get address. Yeah, that should actually be cool. That is actually cool. Cool. Okay, what is the change that I made? 16. Yep, 18 to 16. That is the only change that I made. Now we begin. Right, and here I will compare. No, I will make it a post loop. Yep, and post loop. Yep, post loop. Move into x1, whatever is the value in x0. No, sub x1. Store into x1. Whatever is the value in x0, and store it into x. Subtract 1, right? And then multiply x0 and store into x0 x1, right? After multiplying, then compare. Shit, I lost the main number. I cannot do that, right? I have the main number in 0, which I will move into x1, and yeah, move into x1 what? Move 0 x0 into x1. Yep, this is the destination. This is the base address, right? And do not do that. Do not do that. Replace this with this, and multiply x0 with x1. Right? Compare x1 with till when do I want it to go to keep going back. If it is 1, then branch not equal. If not equal, then branch to loop, and then in the end, branch to loop, and in the end, if I reach this point, then I know that I didn't loop, and I will return. Just simply return. Should that work? Move that. Yeah, that should work. Dot slash out, and that does actually work with some error. Some error. There is some error. What is the error? And fuck it. Right. Array complete the sum array function that accepts the set of rectangle area sum. All right. This takes in a rectangle which looks like this and returns the area, which is cool. Okay. Fizzbuzz. Yep. If a number is divisible by 2, print fizz. If a number is, wait, oh, this is a variation. Fizzbuzz complete a fizzbuzz function that loops over all the overuse is a commonly used overused little toy program that comes up in entry-level interviews. It is a test-based spin on it. Complete the fizzbuzz. Fizzbuzz, yeah. Fizzbuzz is cool. I can do fizzbuzz. And list a division return. It is 2 divided list. Function takes in a list and a number as input. Write the okay, it divides the list by the number and returns it. Yep, a loop and stuff. Join strings. Just join strings taking two strings, and I can don't use the join string method. Concatenate the strings from one end to another in order with a comma between them. That is too simple. Zen of programming. Tim Peters, a longtime Pythonist, describes the build guiding principles of Python in his famous short piece, The Zen of Python. Let's see, that is very short. Well, that is not the whole thing, of course. Python.org itself has the Zen of Python is on python.org, the official website. That is cool. That is pretty cool, actually. Yep, this is the last chapter, which, okay. Beautiful is better than ugly. Okay. Explicit is better than implicit. Okay. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Okay. Sparse is better than dense. Okay. Readability counts. Yep. That, I guess, yes, is true. Special cases aren't special enough to break the rules. Yeah, 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 yeah. Although practically, although practicality beats purity. Yep, practicality does beat purity. Errors should never pass silently. They should be handled. Unexpected, explicitly silenced. Unless explicitly is silenced. But you said explicit. Yeah, explicit is better than. Yes, explicit is better than implicit. Yeah, I read it wrong. I read it in the reverse order. Read it. Shit, read it. Is that it? I read it. Is that the origin? In the face of ambiguity, refuse to the temptation to guess. Okay, there should be one, and preferably only one obvious way to do it. Okay, although that way may not be obvious at first unless you are Dutch. Which is a reference that I do not get. Now is better than never. Yep, just do it now. Although never is often better than right now. Than right now. Yeah. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those. Okay, dash is better than dash. Simple is better than complex. Right. It's okay for special cases to break the rules. Nope, false. An interpretation that's easy to explain, implementation that's easy to explain is a good idea. Maybe there should be a dash obvious ways to accomplish a task. One. Oh shit, why Python? Here are some reasons why we think Python is a future proof choice for developers. Shit. Easy to read and write, popular, portable, interpreted. Code can be executed as soon as it is written because it doesn't need to take a long time to compile like Java, C++, or Rust. Releasing code to production is typically faster. Why not Python? Python might not be the best choice for project if the code needs to be run fast. The code base will become large and complex due to its dynamic type. Yeah, dynamic type will fuck up large complex projects. The application needs to be distributed directly to non-technical users. They would have to install Python in order to run your code, which would be a huge inconvenience. Which language typically allows codes to be released quickest? Python. The best reason to use Python is because its code runs fast. No, false. It does not run fast. It is slow. Python 2 versus Python 3. Okay. Python 2 used this. Python 3 says this. One thing that's important to keep in mind as you continue your Python journey is that the Python ecosystem is fragmented. Python 3 was released on December 2008, but over a decade later, the web is still full of Python 2 dependencies, scripts, and tutorials. In this case, we use Python 3 just like any good citizen should these days. One of the most obvious breaking changes between Python 2 and 3 is the syntax for printing to the console. This changed to this. That is uncool. Should you use Python 2 or 3? 3, as you have probably guessed, you should always use Python 3 going forward. Python 3 and 2 and 3 are similar, but Python 3 contains significant changes that are not backward compatible with two versions. Right, not backward compatible with two. Wait, there a question here like that. Python 3 code is always backward compatible. Nope, false. And then we have completed the whole goddamn course, the whole Python course. Then we have our Linux course, which is this. Tomorrow we will begin this Linux course. That is going to be cool. That is going to be actually fucking cool. Lane Wagner. Lane Wagner. Who is Lane Wagner? I've heard Wagner. fuck, Wagner. Is he from the Scandinavian? Is he Scandinavian? Utah. Shit, that is American. Okay, and right, that is cool. And yep, Lane Wagner. I heard the name Wagner this morning somewhere. Well, there are the Russian crazy people, Wagner, and Nietzsche's contemporary Wagner. He was a writer and he did stuff. Yep, and terminals and shells. Can I see how many individual things they have? Start the course. Let's see. Yo. This one, yeah, I don't have to get into this. And yes, I will be doing this properly, stopping in the middle. If I am only able to do one chapter in a day, I will do one chapter in a day. I will not try to skim through it. Right, that will be cool. And I suppose, shit, this stream didn't even last 1 hour, but that is cool, right? I don't have to make it up. I did what I had to do faster, so